Okay, so when we're going in and calculating the luminosity of a star, in class said we wanted to put it in terms of the luminosity of the sun, because that's something that we actually know. So when you're doing this calculation, so the luminosity of any star compared to the luminosity of the sun is going to be equal to, all right, the radius of the star, which is going to be given to you in the problem, divided by the luminosity of the sun. Well, in all reality, the luminosity of the sun is, or the radius of the sun, I'm sorry, is one solar radius. So your denominator is always going to be the number 1, right? That isn't going to change. When you're talking about the temperature, so the temperature of the star compared to the temperature of the sun, well, we know the temperature of the sun is going to be 5,800 degrees Kelvin. And of course, we're going to raise that to the 4th power. So in all reality, this is going to be the formula that you are going to go in and use when you're calculating each one of these. So if we go down just a little bit then, we have the, assume a star is 10 times the radius of the sun, but half the temperature of the sun. So if we go in and we take our original formula, the luminosity of the star compared to the luminosity of the sun is going to be equal to the radius of the star divided by the radius of the sun, which is going to be 1. And of course, we're going to square that number when we're done. Multiplied by the temperature of that star divided by the temperature of the sun, which is 5,800 degrees Kelvin. And we're going to go in and raise that to the 4th power. So if you look up here at the top, that's where these two numbers actually come from. That's part of the original formula to begin with. So if we plug in the numbers that I have given you, then the radius of the star, according to this, the star is 10 times the radius of the sun. So 10 divided by 1, and we're going to square that number. And then, again, there's 5,800 in the denominator. Now, if the star is half the temperature of the sun, well, half of 5,800 is 2,900. All right, and then we're going to go in and raise that to the 4th power. So that's where these two numbers came from. They came from the actual information of the problem itself. So if you reduce this, then you have 10 divided by 1, which is going to be 10, and then we're going to square that number, multiplied by 2,900 divided by 5,800 is going to be, is going to be 0.5, and then we're going to raise that to the 4th power. All right. Then if you go in and you take 10 squared, 10 times 10, which is 100, so that's where this number comes from, times, if you put in your calculator 0.5 and raise it to the 4th power, you get 0.0625. And so that's where this number comes from up here. So you multiply those together, so the radius, that's wrong, the luminosity of a star compared to the luminosity of the sun, it's going to be 100 times 0.0625. So this star is going to be radiating 6.25 times more energy per second than our sun is. All right, so that's where all the numbers in the PowerPoint problem came from. So what you want to do then is go in and start with your original formula. So this right here, and then plug in your numbers for your radius that I gave you, plug in the numbers for the temperature, and then that will go, and then do the math, and you should come up with your result going in and simplifying it just the way I did this problem right here. So give it a shot. right? Send me your answer and let me see where you're at. If you have any other questions, let me know.